I think tenacity is a character trait you have to have. You have to believe in something tenaciously. You have to have principles. You have to have an honest demeanor and practice rigorous honesty.
Hello, and welcome to the Elevator Careers Podcast, sponsored by the Allred Group. I am your host, Matt Allred. In this podcast, we talk to the people whose lives and careers are dedicated to the vertical transportation industry to inform and share lessons learned, building upon the foundation of those who have gone before to inspire the next generation of elevator careers. Today, our guest is John Koshak. John joined the elevator industry when he was working as an electrician in San Francisco in 1980. John worked in all areas of the field, many office roles, and also in manufacturing and design. John is a NAESA certified elevator inspector and qualified elevator consultant. He is a member of the board of directors for Elevator World magazine, past president of the International Association of Elevator Consultants, and past chairman of the Elevator Escalator Safety Foundation. Today, John works as a consultant and expert witness, among other things. So, John, welcome to the show.
Well, thanks for having me. I'm honored that you asked.
Thank you. I appreciate your willingness, and I know we've had a little bit of interaction over the years, and I'm curious. I was always intrigued by your background and certainly the work that you do. But I'm curious, how did you get started in the elevator trade?
I started on August 1st, 1980. I was an electrician in San Francisco, and a friend of a friend said, "What do you do?" I told him. He said, "Well, you ought to be in the elevator business." And I said, "Why?" And he said, "Well, it pays $19.99 an hour." And at the time I was making 11. And I said, 19, wow. So I had Black Fridays off. And one day I went to 648 Harrison Street, San Francisco, to Westinghouse Elevator at 8 in the morning. I showed up and there was a gal in there named Nan. And I said, "I'd like to speak to Mr. Westinghouse, please." And she deadpanned, "He's dead." And I looked right at her and said, "Well, certainly he left somebody in charge here. I'd like to speak with him." And she took it humorously, and eventually a superintendent came in by the name of Paul Gardner. And Paul said, "Hey, kid, what do you do?" And I told him, "I'm an electrician." And he said, "Come over here. I want to talk to you." And he hired me on the spot. And I started Monday, August 4th. So I started in construction. I did a year and a half as a helper and an adjuster's helper. And if anything, we're going to get to it later. I took prints home with the permission of Eddie Nichols, at the time was the adjuster. And I charted every relay and every contact, every switch. And I wrote down what it did, what I thought it did. And what if I didn't know, I'd ask Eddie the next day. And I think it impressed Eddie. But it was no different than what I did when I was an electrician. You know, you have a plug here, you got a print, put the switch here, put the light fixture there. I just wanted to know what I was wiring and what all this stuff did. And eventually, after a year and a half, they made me a temporary mechanic. And I was doing what was called earthquake. So in San Francisco, in 1981, 82, every elevator had to have earthquake circuitry so that if the counterweight were derailed, it wouldn't crash into the car. So you had to stop the cars and then reverse it away from the counterweight, open the doors, and let people out. And I did that for, 2 years and learned every Westinghouse system, got into Otis systems and foreign equipment because we had very few of it, or very little of it, but we had some. So I had to learn how they did it. You know, essentially it's a box that moves. It's got a motor. You tell the motor, run this RPM, accelerate at this rate, decelerate at that rate. And all the electronics and everything behind it to make it happen is the same. Just this guy does it different than this guy. And so it was a tremendous learning experience, and eventually got into adjusting new Westinghouse hydros and ERLs, which were relatively new at the time. And from there went to Dover and and became an adjuster. Dover was going through a tremendous boom in the Bay Area, and I adjusted Dover composites, probably hundreds of them, and Dover T2s, T1, not T4, and DMC came out, Dover DMCs, and all the Dover systems eventually, and became a Dover superintendent for a while. And as I say, succumbed to the Peter principle, rose to the level of my incompetence, and didn't agree with management. And I was just a young kid superintendent. I really had no say. And the boss said, well, it's been great. See you later. You no longer work here.
Right.
But it was about the concept of super routes. And essentially,
Curious, how long had you been in the industry when you left, I guess?
that happened in 86, 87, I want to say. So 7 years. You know, I'd done construction adjusting. I went to Dover, did construction adjusting. It slowed down. I became a service adjuster, readjusting existing equipment in the field. And so I had a pretty good basis, but not enough experience, I think, to been as mouthy as I was. But I still think it's wrong to give a guy more units than he can possibly manage.
So that's the concept of the super route, as you call it. Is that correct?
Yeah. And the article that's coming out in September in Elevator World, I'll give him a pitch, is exactly, and now that I think of it, it's exactly on this topic, how exactly we ran routes, how we managed and organized routes in 1986, and then what super routes made us do. So in concept, it was you had 3 route men, A, B, and C, and each of them had between 70 and 80 units, and we visited everything monthly. Super routes was take route man B and make him go away, and then give A and C 40 units more. And then we'll have a helper that floats between these two, and he'll handle all the housekeeping and not menial, but the helper tasks, painting, sweeping, mopping.
So it was an efficiency, productivity effort, if you will.
Effort. And I can recall talking with the boss and saying, what happens when route man A is on vacation? And you're going to have a helper under the direction of route man C, because now the helper is under the supervision of, and let's say your route is 50 miles end to end, and he's at one end and the mechanic is on the other, and there's a trapped passenger where the helper is. You're putting the helper in a position where he can't get the person out.
Sure.
Because he's helper, and you're going to make a very unhappy customer. You're standing right here, get him out. And we had that situation happen 2 or 3 times. And it's fraught with other issues. So I left Dover, and eventually I did a year at Montgomery, went back to Dover, and then I went to Amtech ultimately. Amtech was a unique experiment that I think was a good one. Amtech is third party. They don't manufacture their own, although they did make reliable hydros for a while. Their concept was get experts from Otis, Dover, Westinghouse, Montgomery, and we'll hire the best of the best, and we'll give them a bump in scale. So we were paid over scale. And then every week we would have to have training classes. So the entire service department would come in, and the Montgomery guy would explain MIPROM or whatever the crowd wanted, really. And I would do Dover, I would do Westinghouse, and we had an Otis guy. And then I had a half a route. And then the other half of my route was readjusting all the Dover stuff. And so I thought it was a really good blend of utilizing skill sets where they would be most efficient in teaching and in passing on the knowledge, as well as keeping problem units from being problems.
Sure.
And then in 1998, 99, there was a fatality in the Bay Area. A hydraulic elevator fell, and the inspector was a really good friend of mine, and he happened to be re-inspecting one of my jobs the next day after his investigation. Joe Strelick was his name. Joe said, Captain Gizmo, figure out a way to stop a falling hydro. And I said, what are you talking about? And he told me this story where the bottom of the jack had blown out due to electrolysis, and a terrible tale of mother and his son, 90 and 70 years old. And the car plummeted, and he was half in the car. And so that set me on a course where, okay, I'm a problem solver. And I came up with a design that I could stop a broomstick pretty well in my garage. And I went to a machine shop and I scaled it up. And then I went to the repair department and said, I want an old controller you're ripping out, and I want an old cylinder. And I cut it to I think 8 foot. And I set up in the machine shop a working 8-foot hydraulic elevator system. And then I put my device on the top of the jack. And after months of testing, I finally came up with a design that would stop ultimately 100,000 pounds without damaging the plunger. And it was unique, and I was fortunate that nobody had patented in that space with anything like my design. And Adams Elevator and other companies came out and looked at the prototype. Eventually was able to convince, I'll shout out to Monty Montague at the Oakland Hall of Justice. He said, okay, I'll let you put your device on the garbage elevator at the Hall of Justice. And it was a little two-stop, and all they did was it went to the loading dock, and the janitors brought all the garbage there. And I put it on and I filmed it, and I sent the video to different companies, Adams included, and Adams and our company made an agreement. And so for 20 years, I received royalties, which is really kind of cool.
Yeah.
Sent my kids to college. At the end of the day, I was working to help Adams do a startup of the manufacturing. And I would work half-time at Amtech until one July 4th, the day after 4th of July. Ironically, here we are.
Right.
My boss at the time said, we can't expend these resources anymore. We're going to have to let you go. And I said, okay. So I went to Adams, and they said, well, great, we want you to work here. So I became the vice president of tech support, and we finished the testing of the life jacket, and I became familiar with the 17,000 parts of Adams manufacturing, which included door edges and limit switches, I mean, you name it, Adams made it, fixtures, rollers. And I would be the department that somebody would call and say, hey, your gizmo is a piece of crap, it doesn't work. And I would say, hold on, let's examine it. And I would go to the field and I would look at, is the mechanic installing correctly? Is the manual wrong? And so I would write manuals. I would come to the root cause problem, which may have been in manufacturing. And so I learned manufacturing. I was there for 5 years. And then Schindler said, we don't want to be in the product business anymore. And they sold Adams. So when I sent the video to Adams in 1998, it went to a gentleman named Dick Gregory. And of all the people in the industry, I consider Dick my mentor. There were many mentors, Gene Heck at Westinghouse, Eddie Nichols, I mentioned, other people that influenced and provided me opportunity and knowledge. But Dick was special in that Dick saw something that I didn't even see. And he said, this is a really good, the plunger gripper, the life jacket as it became called, And he convinced Bob Healy at Adams to take it on as a product. And when Amtech let me go, Dick left Adams to go full-time into his consulting firm and recommended to Bob that I be his replacement. So 5 years later, Dick said, as we did every month, we had sushi.
Right.
I'm at lunch and with him, and he says, well, what are you going to do? And I said, well, I'm a California guy. I'm living in Chicagoland. I don't want to join Local 2. I'm a Local 8 guy. And he said, his phone rang, hey, literally right then. And he said, hello. Yeah. Yeah. Hold on. John, what are you doing tomorrow at 8 o'clock? I said, nothing. He said, yeah, I've got a consultant, John Koshak. Meet Bob on the loading dock. Okay, great. Click. And he said, see, you're a consultant.
Just like
And I said, Dick, I have no idea what that means. And he said, yes, you do. You just don't know you do. He said, go out there and write a report and tell me what went wrong. And it was a Dover composite right up my alley. It
Sure.
was a problem. Don't want to mention company names. And I wrote a report. Dick said, well, change this a little bit, change that a bit. Great report. And start a company and send me a bill for your report. And I said, that's it? He said, well, yeah, you need a license for this and an LLC and Dick walked me through. And without Dick, I don't think I'd be here today.
Sure.
So I became an independent consultant for Vertex, Dick's company. And shortly after that, I got a call from a gentleman, another mentor named John Brandt. And John Brandt at that time was the CEO of ThyssenKrupp. And I'd met him earlier and through the years. Anyway, he called up and said, I'd like you to work for me. And I'd just been through the Schindler grinder. And I said, appreciate it, John, but thanks, but no thanks. And he said, no, we're different. I said, I don't think so. But he convinced me, and he said, it's a special project. I can't tell you what it is, but it's right up your alley. I want you to do it. And I said, okay. And it turned out to be designing an elevator,
Wow.
brand new, utilizing Kevlar ropes. And it was to compete with the Gen 2 and the Coney monospace. So armed with my knowledge of patents, my knowledge of the mechanics of elevator components, armed with my knowledge of the code, because when Life Jacket became a thing, I joined the code committees.
Right.
And so now it's my job to make Kevlar rope something that's accepted by the code. And that was a tall order. And then we had failures. And the project eventually was scrapped. And I stayed on. John asked me after that to remain on as the director of codes and standards because of the director at the time, a really great guy named Davey Camp, passed away. And so I became the director of codes and standards for ThyssenKrupp Business Americas unit. So I was coordinating A17, EN81, AS 1735 in Australia, the Japanese, because we were a global company, we had global codes to consider, and
Sure.
wherever we were, we tried to make one thing comply with all codes. And then there were issues with the branches and their local authorities. And so I was dealing with all of them, all the chiefs that we were in almost every major market. And then John retired and another fellow took over and he said, it's been swell. How many days you've been working here, not counting tomorrow? And I said, wow, just like that.
Wow.
And the closer you are to the sun, as Icarus noted, you need to use a hotter melting wax, which was fine. I was then free And now I'm 7 years further away from the field. And Dick called up and he said, "Hey, I heard a rumor." And I said, "Yeah." He says, "Well, what are you going to do?" I said, "I think I'm going to go back into consulting." And I did. And it was then that Dick sent me my first attorney client. He was busy. He told the lawyer, "Call this number, ask for John." And I was off to the races. But it was minimal. It was, most of my work was doing specification for mods, new construction. Many components require certification by UL, CSA, and independent companies need that same service. They just, suddenly I'm on the market and I can help them. So many companies in the industry approached me and said, "Can you help us get this through certification? Can you help us get this into the code?" So my consulting business was very limited and focused to a lot of code requirements, dealing with, again, authorities who have a problem with a particular design. And I would help the company either change the design or change the mind of the jurisdiction or write variances. And over the years, it's just shifted from less certification work, less specification work to more and more forensic work. So that's
Yeah.
a nutshell, but that's my nutshell.
Yeah, no worries, no worries. So it sounds like you do a lot more, like you say, the expert witness these days than certainly early on. But is that the primarily what you do? Is help when there are legal issues? In other words,
Yeah, I want to say this in a way that's not offensive or unclear. We live in a world in the US where, we write contracts to perform services for money. And it's no different for elevator maintenance or even a new construction or a mod contract. There are clauses that say, we, the elevator company, will do X for X dollars.
sure.
Okay, well, things break, things malfunction, things don't work necessarily as intended, and people get injured. And so they, of course, call attorneys. And I'd say 15 years ago, I thought poorly of people who did that. But the more I'm into this, there is true harm that has occurred and does occur.
Sure.
And being a consultant who is the guy that goes the next day after a fatality, for instance, at first it was exciting and interesting because you're curious what happened, to now it's, I dread it. When I have a Google alert that says someone's been killed, I'll get a call within a day or a week or 2 months. And it's not just me. I mean, there's probably 10 industry players who do this work.
Sure.
And every one of these cases have multiple defendants, sometimes multiple plaintiffs, and every one of them have an expert. And it's a diverse crew of guys. I think we're all generally friends, but we're generally always on opposing sides, and we can never discuss it until it's finished. And we poke each other in the eye and we move on and let the juries and the judges and, decide what the facts are.
Sure.
Based
Sure.
on the evidence we find.
Yeah. I mean,
So-
it's definitely a high risk, industry, whether you're working on them or, like you say, it's the writing public, maybe, less, we don't, as an outsider, as writing public, we don't have a lot of training before we write them. We just hop on them and expect them to work. And you obviously see the times that they don't quite work as intended.
Yeah. Yes. And there were so many stories. I could tell one day I'm going to redact all the names and write a book of the cases. And actually, I started writing for Elevator World. When you look at section 8.6, it speaks specifically about what are called applicable components.
Mhm.
Essentially, these are components that when they break, generally will cause hazard or injury. Door locks, buffers, doors, door systems. And the code says that these 18 or 19 things, now 22 things in the electric code, have to have maintenance done to them. That's what 8.6 is all about.
Sure.
You have to determine the frequency that you do the maintenance. You have to provide the procedures, and you have to record when they're done, etc. So in writing for Elevator World, I set myself out on a mission that looking at my cases, what are the lessons learned? What would be beneficial for elevator mechanics, helpers, companies, owners, to understand what failed
Sure.
so that it doesn't happen to them. And I made them, Risha, Hendrick, and T. Bruce McKinnon, made them continuing education articles that people can read them. And I write a 10 or 20 question test, and they get an hour CEU for it, for continuing education.
Sure.
And so my goal was to complete all the applicable components and then start over with, the different scenarios, because generally it's the same things that keep hurting people when they
Sure.
break. So between writing a book with all my redacted reports, I'm writing contemporaneously after the cases are completely finished. Just explain, what the code requires, why this is important, and this is what happens if you don't do this. And then hopefully somebody learns that lesson and will take that to the job with them the next day.
Right.
So
What would you say is, I don't know, is there, obviously we do, you do safety training in the field, and what are some of the bigger contributors to minimizing those failures or accidents or harm, as you've called it?
Yeah. Providing mechanics enough time to do the tasks. That's where we fail. And again, this article in September is specifically on this point. And I go into a little bit of detail in the article. I'll go into even less detail now. At Dover, we would have, in the 80s, early 80s, we would assign 70 to 80 hours of maintenance. And there were 172 hours on average in a month. The units, we always had an hour for hydro and 2 to 3 or 4 hours, depending on the height of the rise of the building.
Wow.
For traction. So the job of the salespeople was to go get enough money to cover 1 hour for hydro or 2, 3, or 4 hours a month for traction. And if we couldn't get that money, we'd say no.
Right.
We'd let or whoever. But we would get the money. So therefore we had the time to actually have the mechanic do that. And my job as a superintendent was to go and look at the job. Is this guy that we hired, he's a nice guy, he's a smart guy, but is he doing the work? And you can't know unless you walk on the job and look at it. And there were written standards. Everybody knew what I expected of them. And my metric was always callbacks. If your callbacks exceeded a certain average of callbacks per unit per year, then I would send an adjuster. If I would go to help you reduce your callbacks, because technically you're not getting the job done. And for the technically oriented mechanics, their jobs were typically filthy because they were, I don't want to say prima donna, but I've been accused of that. I would send helpers to do the painting and sweeping and mopping. So that's how I managed. I managed by the callbacks, and I managed by the assistance that the mechanics wanted or needed by my estimation after supervisory visits. And that doesn't happen anymore. when you read contracts, they'll always generally, if it's non-OEM paper, and even some OEM paper will say, and we will do an annual survey. We'll send a supervisor out to make sure everything is hunky-dory. And if what I see when I look at these cases, when I look at these elevators, is acceptable to supervisors today, then we've got a problem, because these jobs are absolutely filthy. I've got 100 stories.
Sure. So do you see a difference? I mean, it sounds like there are, some bad players who maybe aren't showing up. Do you see a difference? And again, not to mention company names, but do you say that, hey, certain companies are absolutely doing what I would have expected 20 years ago, or,
So the theme of my article in September is major companies have adopted this super route concept, and they're all in. I've had cases, and I've had to interview and the pleasure of speaking to mechanics around the country. Some mechanics are loaded with 350 units.
Wow,
that they have to maintain. That's a lot of callbacks. I didn't finish it at Dover. I said we managed the callbacks, but we didn't give the guy more than 130 hours, because we knew he'd have 40 hours of callbacks,
sure,
or unexpected repair, or soccer practice, or he might break a finger. We knew that. And so we didn't give him 172 hours of maintenance.
sure,
But that's apparently what goes on today in the major company sector of the industry. They'll give so many units that it's overwhelming. And then when you don't do maintenance, your callbacks increase. And so now you're just doing callbacks, and you're not doing any maintenance at all. And I think that's the first failing. Who does it well? The independent companies. Every independent company that I'm aware of, they go monthly. And I believe in that. I believe that for a mechanic to go into a machine room and smell, feel, hear, taste, use all of his senses when he walks in a room. And if you're familiar with the room and the equipment, you can hear when it's wrong. You can smell when there's something burning.
Sure.
I think what made part of this possible was, again, another computer invention of the early 80s or late 80s, early 90s, was remote elevator monitoring. It's great in concept. It's a great supplemental tool, but I believe that remote elevator monitoring by itself cannot supplant a mechanic. When I was in the field still, REM was the acronym that mechanics called remove elevator mechanic, because that exactly was what it did. So they would monitor 8 or 16 voltages and come up with a truth table and say, wow, the door didn't close in 30 seconds. And then they would page you and say, hey, the doors aren't closing at the elevator. And so you drive up.
Sure.
And that's a very simplistic example, but that's the example that is maintained, is the good example.
Sure.
The other examples are not so good. You cannot decipher 16, 8 voltage levels to determine that a relay burned up. That's affecting group dispatching. It can't know. It's just not smart enough. But then you fast forward to computer elevators, and okay, now you can transmit more than just a byte of data. You can send a whole packet of data. You can send REM fault codes that computers generate that say, this is something that the designer foresaw, and it shouldn't happen. We're going to give it a fault, a 1207, and we're going to ship that on our REM. And ideally, the mechanic, his phone beeps, and it says, hey, there's a 1207 fault at 123 Main Street, car 4. And maybe in the beginning of time, that's how it worked. But today, it doesn't work like that. Mechanics have no idea what REM even does. They don't get the REM reports, at least in the depositions of the people who I asked this specific question. So I question whether REM is doing everything that it was promised to do. But I think there's a reliance on it that is detrimental to the industry. As I started this topic, I said it's a great supplemental tool.
Sure.
But it's not the
It's not
only
the,
thing. It cannot replace a mechanic. So I stress that. And as the world's going more and more IoT, I'm seeing more and more larger independent companies start thinking, wow, this REM thing, this really got some legs. I can put an IoT, I can measure the temperature of the motor.
Sure.
And yeah, you can. You could measure the temperature of the oil. You could do a lot of things. Until they're as smart as a mechanic, I think it's a great tool that supplements a mechanic. And you do want to know the problems before your customer does. That is a tremendous advantage. And it increases safety. But again, I think it's got to be realistically within the realm of understanding and believing that you still require a mechanic showing up. So
yeah. No, that's a lot of insight there, and it looks like you're you're certainly working on some some difficult challenges and cases, and it'll be interesting to see your article when it comes out in September. But we're kind of starting to run out of time here, so I'm just curious if you could give us a little bit of I don't know, some sage wisdom. What would you offer to the industry, or maybe to someone who's even following in your footsteps? What have you learned?
I think tenacity is a character trait you have to have. You have to believe in something tenaciously. You have to have principles. You have to have an honest demeanor and practice rigorous honesty. I think that's first and foremost in any endeavor in life.
Sure.
And it's, I think, true in the elevator industry. To be successful in our industry, in my opinion, you have to be the one who says, I want to take the prince home. I want to understand this as well as the mechanic. There are mechanics who won't teach you. There are mechanics that will spend all their time teaching you. You can't get mad. You have to just be tenacious and find that guy, or do it on your own. But you have to show up. You have to be there on time. I was never late if I could help it. It was, I would have had to have my legs cut off. I was the guy there 15 minutes early. I never left early if I could. And, I never did it. I wanted the mechanic to be so satisfied. If I stood around doing nothing, I would grab a broom. I would go buy a broom and clean the machine room when I was in construction. Being honest, being tenacious, I think it's rewarding because the elevator industry offers so much. It's not just learning electronics, electricity, plumbing, carpentry, welding, bolting, materials. You get to do it on the Hoover Dam. You get to do it on this Golden Gate Bridge. You get to do it at Genentech or Lawrence Livermore, Berkeley, Oak Ridge Laboratory. You get to go to all these places. Not all of them are, the two-stop at a strip mall with an orthopedic office. But even there, you meet new people. You get to see and do. Very, very few people get to do what we do, and it's pays very well. It should. It's a very risky job. The last thing I would say is safety has to be paramount. You have to always know where your fingers and toes are. You always have to say, I'm moving the car. Are you clear? If you're working with somebody, make it your habit to always end and begin every movement with a warning. I'm going to stop. Coming home to your wife, your family, your kids is the most important thing. And we practice safety. There are people who don't practice as much safety as likely they should, and many of us have paid the price. I had a occasion to actually have to look at the number of fatalities in the industry, and it was a scary number.
Sure.
It's almost eight a year. I had to go to a code meeting at the Elevator Industry Work Preservation Fund in Foxborough, Mass, and they have a memorial wall there with a plaque of all the IUEC mechanics. And of the 222, I knew 8 of them personally.
Yeah.
And that brought a sobering realization to me that this truly is a very hazardous trade, and you have to pay attention. So safety, honesty, tenacity, and be there when you say you're going to be there.
Thank you, John. No, I appreciate those words of wisdom. Thank you so much for your time, and I wish you the very best in your work.
Well, thank you, and I appreciate the opportunity. Bye.
Thank you for listening to the Elevator Careers podcast, sponsored by the Allred Group, a leader in elevator industry recruiting. You can check us out online at elevatorcareers.net. Please subscribe, and until next time, stay safe.